All right, so we're going to continue on with what we were doing last time. So we're talking about quadratic functions and what's known as vertex form. So just a quick review of what that was. So if you have a function in y, which is, remember, is the same as f of x. So you can use f of x or y, depending on what they feel like doing, is going to equal, there's potentially a number out front. They call that a. All right. Then you have an x squared term, but it could have something with it. So it could just be x squared, right? But if we shift left or right, then we subtract off some x value, and that x value is part of the vertex. Okay, so that's this guy. And then you could move up or down by adding on some number that they call k. Okay, so when you've got a vertex like we've got here, the vertex is either this minimum point or this maximum point, depending on whether your graph is going up or down. And whether your graph is going up or down, this one here would be a, the number out front, is positive. And over here, this would be a, is negative. Okay? So that tells you whether you're going up or down. Then this vertex point, it's an xy point. And for some reason, they like to use the letters h and k. Okay? So the purpose of that is when you plug it back in here, or they give you something in vertex form, it's really easy for you to tell them what the vertex is. Okay, so for example, if I had something like y equals x minus 3 squared plus 5, okay, and they ask you for the vertex, it's really easy. Here's all you have to do. So you switch the sign on this guy. So instead of minus 3, he's positive 3. And you leave this guy alone. There's your vertex, 3, 5. So that would be like this guy right here, would be 3, 5. Okay? And then by the same token, if they gave you this for a vertex point, you could put it into vertex form by setting it up like this, switching the sign on him, and leaving him alone. But it's always going to be f of x or y equals some version of x squared, and then just an extra number tacked on. So that's vertex form in a nutshell. All right. All right. So we did some problems there last time. We're going to just wrap the rest of them up today, and we'll call it a weekend for you guys. Not too bad, right? So let's see what else we got. So as you can see, we did a bunch of stuff last time. We got a few more things to work on. All right. So this says identify the vertex axis of symmetry. I didn't talk about axis of symmetry. That was my bad. Let's back up for a second. Let's talk about what that is real quick. So the axis of symmetry is a line that goes straight up through here, and it goes through the vertex, especially if I drew a little better. Okay, and it splits this thing into two mirror images. So this is the axis of symmetry right here. Axis of, and I'm not going to write out the symmetry. Axis of sim. A of S. All right, and all that is the x value of the vertex. So literally, the equation of this line is just x, in this case, equals 3. So that's really easy as well. Okay, but I neglected to mention that, so we'll go back to what we were doing here. All right, so back to our regularly scheduled program. There we go. So identify the vertex, axis of symmetry, direction of the graph in each function. It says compare the width of the graph with the width of the graph for just basically f of x equals x squared. And when you have the simplest version of any function, which in this case would be f of x equals x squared, there's no up, down, left, right, it's just there, right? That's what's known as a parent function. Okay, I don't know why they don't bother to call it that, but that's the deal. Okay, and we didn't talk about what the number out front does. I mean, not today, we talked about it last time, but we'll come back and we'll talk about that here in a second. All right, so again, to find the vertex, the number that's in with the x, we go ahead and switch the sign, and the other number we just leave alone. So in our first guy here, what would our vertex be? Again, this is some xy point. So the first part would be -1, good. And what's the second guy? Remember, so we just leave the second guy alone? Yeah. So that's your vertex. Easy peasy, right? Axis of symmetry is just x equals the first number. So it's going to be x equals -1. So that's your axis of symmetry. There's your vertex. Okay. So it says the direction of the graph in each function. So this is where that number out front comes into play. Okay. So in this case, we've got a +2. So does that mean does our graph go up or down? What's positive usually mean? Yeah, it goes up, right? And then the other thing to consider is if you've got a 2 out front, we're multiplying this guy by 2, right? Anytime we multiply something by 2, what happens? It goes up twice as fast, right? Okay. So then it says, what is the direction of the graph? It's going to be up. And since we have the 2 out front, what that does for us is it's going to make our graph a little skinnier than normal. So it'll be kind of like that. So it's going up pretty fast. And that's everything you need to know. So you can get a lot of information out of this vertex form. All right, so how about our next guy? What's our vertex for this guy? So this is going to be +3. What's our other number going to be? Yeah, -3. Easy and peasy. So axis of symmetry is just x equals the first number. So that's just 3. How about this guy? We going up or down? Yeah, we're going up. We don't see a negative sign. We don't see any number out front, but that's okay. Because you know how it is in math. If they don't put a number out front, technically it's 1. Right? So this is +1. So it's going up. And then as far as the width, since this is 1x squared and this is some version of 1x squared, then the width on this one is going to be the same as the x squared. Okay. Cool. All right, so how about 31? Let's talk about him. So we'll start with the vertex. What's our vertex going to be? Is the first guy -5? Yeah, +5, right? And then what's the second number? Yeah, so 5, 6. And then our axis of symmetry is just going to be x equals 5. So it's just x equals the first number. So this time, up or down? We got a negative sign, though. What's that do for us? Yeah. So the first two guys are positive. They're going up. This guy's negative. So this one will be going down. Okay. And now we've got 0.75. It's negative, and then it's 0.75. So is this graph going to be wider, skinnier, the same as x squared? What do we think? We can break out the Desmos if we need to on this as well. Skinny is usually when we have a number like 2. Here we've got a fraction between 0 and 1. So what's that going to do for us? Yeah, so it's going to be a little wider. So it'll look more, well, actually, it's going to be upside down. So let me fix that up. So this will look more like this. It'll be going down, and it'll be a little wider. So something like that. Good. All right, and how about the last one? What's our vertex here? Yeah, so switch the sign on the first guy. And what's our second guy? Yeah, leave the second guy alone. Same pattern every time. Then axis of symmetry is just x equals the first guy. So that's minus 2. So how about this guy, up or down? Okay, so he's going down. Good. And now do we have a wider graph or a thinner graph? We got a minus 3 there. Or is it going to be the same as x squared? So again, wide is when you have like a decimal number between 0 and 1. So this is 3. So that means this thing is going down 3 times faster. Okay. So that means it's going to be going down, and it's going to be kind of skinny. Okay. So it follows the same pattern. If you've got a number bigger than 1, you get a skinny graph. If you've got a decimal number between 0 and 1, you'll get a wider graph. Positive goes up, negative goes down. That makes sense, right? If there is no number, like in number 30, then your graph is going to have the same shape as your x squared up here, because that's 1x squared as well. So if the number out front doesn't exist, or they do put a 1 there, which is doubtful, but they might. Okay, so if this one's 1, that means this one's also 1, and that's why this guy was the same. That's pretty much it. That's pretty much how these things work. They're not that bad. Okay, questions? Okay. You know, Chloe's not the only one here. You guys can chime in anytime. All right. All right, Chloe, I appreciate your help, though. All right, so let's check out another one. Oh, no, we have to graph. All right, so let's talk about how we would graph this thing. So let's kind of do the same thing we were doing. What's our vertex going to be in this case? So it's going to be 1, and then what's the other part? Yeah. So that's going to be the bottom of our graph, right? Well, I shouldn't say that it's going to be the bottom of our graph. I know that, but I want to know why you guys know that. So then we go over 1 and up 4. And there's our graph. So there's our point. That's either going to be the top point or the bottom point. Now, how do we figure that out? That's determined by this guy right here. So from that point, are we going up or down? Yeah, the vertex is the bottom in this case because we're going up. Good. So if we're going up, that's going to be the lowest point on this graph. Good. Okay. So now here's a little hack. So this is a 2 out front. Here's a little hack for you as far as the first point here. So if we go over 1 point from 1 to 2, okay? So if we go over here to 2, what this will do for us, if we plug in 2 minus 1, that's 1, and 1 squared is still 1, right? But then we have 1 times 2. So kind of think of it almost like a slope, even though it's not going to be a slope. This is how this is going to work. If I go over 1, I need to go up 2 because of this guy here. Over 1, up 2. Draw ourselves a point. Choose our purple guy here. There we go. And then remember we talked about how these things are very symmetrical, right? So what that means is if I go back 1, it's going to go back 1 and then again up 2 because it's symmetrical, right? So if I go back 1 to 0 and I go up 2, there's my next guy. So this is enough that we can kind of tell what this thing's going to look like because we know it's U-shaped, right? So we just kind of do this. And that's all we need. And then if you want to just kind of spike the ball and say, well, I also know that the axis of symmetry is just x equals that first number. So you could have an axis of symmetry here as well. It just goes up through here. And again, that just kind of divides it into 2 mirror images. Okay? But you don't really need that for the graph. How do we get to 6? Okay, good question. So let's just do the whole thing. All right, so we started off, we had x equals 1, right? So if I put 1 in here, I get 1 minus 1, so this whole thing is 0, right? 0 squared is still 0, and 0 times 2 is still 0. But I got this plus 4 to deal with, right? So that's there. And that's our vertex, right? There he is. Okay? And this is y over here. This is y over here. Okay, so then I said, well, let's move 1 over. Let's go over to 2, right? So if we do that, let me clean this up here real quick. So if I go here and plug in a 2, I've got 2 minus 1. So this whole thing becomes 1, and that's 1 squared, which is still 1, right? Times 2, so this will be 2, and then don't forget about this guy, plus 4 is 6. So that's how we got the 6. Okay? So then when x equals 2, y equals 6. So let's do one more. Let's go back 1. Let's go back to 0. Okay? So let's do that. Let me clean this up again. All right, so this time, if I throw in 0 here, I got 0 minus 1. That's minus 1. But when I square minus 1, minus 1 times minus 1 is actually positive 1. Then don't forget, we're going to multiply by 2. So 2 times 1 is 2, right? And then plus 4, so we get 6 again. And that's how we got those. And like I say, in this case, since we're running out of real estate up here because the graph's pretty much up at the top, those 3 points are pretty much enough because we know this thing's going to be curved. So it's going to go like this, and it's going to go like this. Okay, great question. So that's how we do the graphs. And if we're doing graphs like that, always feel free to check yourself on Desmos. All right, so let's try a couple more of these guys. Okay, so then same deal for this one. We find our vertex. So vertex is switch the sign on him. So it's going to be positive 0.5 and leave this guy alone. Okay, so that's our first point. So this one's going to be a little bit of a pain because it's a half. So we go over halfway between 1 and 2. We go up 1. That's going to be our starting point about right there. Okay. So next thing we want to look at is we'll look at the guy out front here. So are we going up or down? Yeah, so this one's going to go down. And since we got the 2 there, we're going to do the same type of thing. So after a while, like I say, you don't even really have to plug in the points because you can look at it and say, all right, well, if I go over 1 here, so that'd be like to 1.5, I'm going to go down 2. So that would be like down to here. Let's go ahead and plug in a point there. All right. And then the same deal, if I go back 1 to -1, I will once again go down to, well, actually, it's -0.5, my bad. It would be down here, like that. Okay. Now, if you wanted more points, all you have to remember is, like I say, when you do 1 squared, that's just 1, right? But then you multiply it by the 2 out front. So that's why we went down 2 in both cases. Now, if I increase by 1 more, then that would be increasing by 2. 2 squared, 2 times 2 is 4. So we go down 4, but then don't forget, we got to multiply by the -2. So we have 2 times 2 is 4 times 2 is 8. So I don't even know if we have enough room to go over there. So if we go over 2 and we go down 8, yeah, we're all the way down to the bottom here. So these things move fast. So I go over 2, I go down 8, so there's a point there. And then same thing over here. If I go back 2 and down 8, then we got a point there. And that's way more than enough that we need for this situation. So this guy here is going to look like this. Okay. So if I was having you do graphs like this, the main thing I'm looking for is I want to know that you know the vertex. And then, like I said, this graph's going to be a little skinnier because of this -2. So we know that's going down, and it's going down a little faster. So that's our guy. Okay. Not looking for perfection because my graph certainly isn't perfect. Okay. But we get the idea, right? Questions? Let's check out a few more, make sure we got it. All right, so this one, figure out our vertex. Always start there. So we switch the sign here. Leave the other guy alone. So this one is going to start at -2, 2. So we're going to go back 2, right, and up 2. So back 2, up 2, there we go. So there's our vertex. All right, so the number we got here this time is 0.5. Positive 0.5. So is our graph going to go up or down? Yep, he's going up. So our vertex will be a minimum point, right? Okay, so for this guy, use the number out front, and we say, all right, well, if I go to the right one, I'm only going to go up a half this time, because this guy's only 0.5. That's only a half, right? So I go over here to -1. I just go up to 2.5, about there. Okay. Then I do the same thing over here. If I go back 1, I'm going to go up 1/2. So as predicted, this graph's going to be a little bit wider because we have a number less than 1. Okay. Then to figure out the other one, if I go over 2, you take 2 and square it, right? Because whatever's going on in here, if we've increased this by 2, it's pretty much 2 squared. That's going to be 4. But then we have to multiply it by the 0.5. 4.5 is 2. So if we go over 2, then we have to go up 2. So we start at -2, we go over to 0, and then we go up 2 from +2, so that's going to be the 4. And you can actually plug in the numbers and get the 4, but if you use the symmetry of these things, it makes it pretty easy. So same deal, if I go back 2 from -2, I go back to -4, and I go up to 4 again. So notice these guys are always kind of across from each other. All right, and like I said, that's more than enough for what we need here. So this thing's going to kind of go like this. And if you miss your point, just make your point bigger. That's what I always do. All right. So then that one, like I said, we were predicting this stuff early on. Before we start actually doing the graph, we said, okay, here's my vertex. Axis of symmetry, you don't really need to graph. It's nice to know that it's there, but you don't really need it. And then what we basically did was we plugged in some numbers on each side of it. We plugged in -1 and 0. And we also plugged in -3 and 4 and figured out what our points are. And that's all we need. But you can use the symmetry of this thing as a pretty good hack. All right. Let's try one more. All right, so this guy, like I say, always start with your vertex. Switch the sign. Leave him alone. And there's our vertex. So we go to our graph, we go over 2 and down 2. There's our guy. So that's our vertex. So this one, we're going up or down? Yes, this one's down, right? And then we've got the 2 out front. So again, just kind of use the symmetry of the thing. We can go to the right one, and then we'll have to go down 2. Here's a point. Go to the left one, also go down 2. Very symmetrical. Quite frankly, that's enough for what we need. We know it's going to basically look like this. And that's it. Way easier than you thought, huh? So find your vertex, use this guy here. So if you go to the right, go down 2. If you go to the left, 1, go down 2. And that's it. And like I say, feel free to check these on Desmos if you like. All right, a couple more and we're out of here. So it says each line represents a quadratic function. Write each function in vertex form. Okay. So here's our vertex, right? So if we're writing vertex form, we're going to have y equals some version of x squared. Switch the sign on this guy. So he comes x plus 1 squared, right? And this guy we just leave alone, -4. Okay, so the other thing we need to look at is if I go over 1 in this direction, how much did I go up? If I went over 1 block, how many blocks did I go up till I hit the graph? So how far is it from here to here? Not 4, just 2, right? 1, 2. So what that tells us, and since it's going up, we know it's going to be positive. And if I go over 1 and up 2, that means the number out front here is 2. And that's your answer. Okay? Okay, so the other one, start with our vertex, same as always. So we're going to say y equals, leave a little room here in case we need a number, some version of x squared, right? And then we take this number here, switch the sign. So x minus 2 squared, leave this guy alone, so it's just plus 5. All right, we're going down, so we know there's going to be a negative sign here, right? And then same deal, if I go over 1, how much do I go down? So it looks like if I went over 1, that's 3, and I went from 5 down to 2, so we went down 3, right? So this will be a minus 3 out front. That's it. So the equation of that guy is minus 3, and then in parentheses x minus 2 squared plus 5. Done. That's it. They're not hard, so don't make them hard. All right. Done. Done indeed. All right, let's check out one or two more. We got 2 more things, so we got like a standardized test question, then we got like an ACT question, and that's it. So we're almost there. All right, so here we have our function. It says it's graphed on the coordinate plane. Select all true statements. So it says the graph opens downward. Downward means a negative number out front. We don't have that here, do we? So he's wrong. The vertex is minus 3, 9. Remember, we got to switch the sign on this guy. So it should be positive 3, 9. Nope, he's gone. Axis of symmetry is x equals 3. Switch the sign to get the vertex. The first guy is 3. Check. That one's cool. It says the y-intercept of the graph is 9. All right, so the y-intercept is when x equals 0, right? So if we look at this, we say, all right, if I put a 0 in here, then I've got negative 3. Negative 3 squared is 9, right? 9 times 2 is 18, plus another 9 is 27. So it's definitely not 9. That's wrong. And it says the minimum of the function is 9. So again, this guy's going to go up. And we know that our vertex is going to be positive 3, 9. So in terms of y, that is the lowest point on the function. So that guy's good. Check. So C and E work out. Okay. So the key on this one is the y-intercept. You just plug in 0 for x. Okay. All right. Last one. So it says the graph of g of x equals x squared is translated 2 units down, no, 2 units right, and 10 units down. So it says, which of the following is the function of the new graph? Okay, so 10 units down means we're going down 10, right? So all these guys seem to work except this guy's stuck in here with the x. So that's no good, but everybody else is still in the running. Now, we already said that unless you haven't moved left or right, if you haven't moved left or right, then it's an x squared, just an x squared, no parentheses, right? But we don't have that here. We've gone right 2 units, right? So that makes these guys out. Because this would be x squared, or this would be, yeah, x minus 0 squared, which means you haven't moved left or right. So that guy's out. So 2 units to the right. Remember, this does the opposite of what you think. So since I see a positive 2 here, I need to switch my sign and go with negative 2 here. And that's my guy. Make sense? All right. All right, ladies and gentlemen, that wraps up quadratics in vertex form. We'll start a new topic next time, but it is Thursday, which means you guys don't have to show up tomorrow. So it's weekend time for you guys as far as algebra is concerned. All right. I've already got attendance, so you're good to go there. I'm going to go ahead and stop the recording. And